Hello everyone, my name is Taissir Boukrouba. I'm an intern at the Sparks Foundation for the Data Science and Business Analytics Internship. This video is an overview of the first task, which goal is trying to predict the score percentage of a student based on the number of hours studied or spent studying by the student. For the model, we're going to use a simple linear regression model as our data only involves two variables. The steps are as follows. First, we import libraries, then we load our data, we do pre-processing, we visualize our data. Afterwards, we do iteration, which means splitting the data, then training and testing. Afterwards, or finally, we evaluate how good our model is. As for the libraries, we have pandas SPD, which is used for data pre-processing, matplotlib for visualizing our data, linear regression, which is the library of our model, train test split to split our data, and finally a metric which is called mean absolute error, which is used for to evaluate our model. Here we are loading the data. As we can see here, we have 25 rows or instances and 2 columns. We have here the index labels, the hours column and the scores column. As for the hours, for example, a student which studies 2.5 hours will get an average score of 21%. For 5.1 hours, he will get or she will get about 47% of score, etc. for the rest of the table. After loading our data, we do some pre-processing, which includes cleaning our data and transforming it. For cleaning it, we are going to look for missing values and clean them if found. And for data transformation, we are looking for the categorical variables and we transform them into numerical variables to be able to use them in our model. As we can see here, there is no null values, so our data is clean. And for the data types, all of them are numerical, so no need for data transformation. Now it's time for visualizing our data. As we know, our brains work more efficiently when there is data or information in form of imagery or image data rather than textual data. As we can see here, this is the distribution of the scores. About 4 instances of 20%, 2 instances of 90%, etc. etc. Here we are using the box plot, which is basically used to investigate outliers in our data. As we can see here, there is no outliers. We can also read from the box plot the mean, which is the average, about 47%, and the mean, the max, and the quartiles. The previous visualizations aren't as important as this one, but it is always a good use to visualize the distribution or investigate for outliers in any cases. Here we are seeing a scatter plot of time spent studying by the student by scores. We can see there is a general uprising trend where the more time spent studying by the student, the better or the more score he will get, the score percentage he will get or she will get. After visualizing our data and understanding it, we go over the iteration phase. First, we split our data as usual to inputs and outputs. Then we train test split our data using the train test split library with a test size of 20%, meaning about 5 rows for testing and 20 rows for training. Um, After splitting our data, we go over the training. We initialize the model, linear regression, and we train it by using training data. Afterwards, we see which predictions will be given by our model. As we can see here, there is 5 prediction, which is the test size of which was given before, 20%. We have 1, 2, 3, 4, 5 predictions. To visualize how good our model is, we try to plot the regression line and plot our data. As we can see here, the regression line is trying to imitate the general trend of the data, but there is some errors here and there. You can see here he missed some values. To see this error in precise, we have to go over the model evaluation. Here we have created the data frame of the real and predicted data. When we visualize it, we can see here that our model is doing pretty well, but there is a little bit of error here and a little bit here, where the model is either predicting less, like we see here, or more, like we see here. To see it more in details, we use the mean absolute error, which is the difference between the real and predicted values, which is about 4, as we can see here, meaning the model either predicts 4 values more than the real values or 4 less. As we can see here, the model predicted 4 less. The real value is 20 and the predicted is 16. Here we are seeing the model score, which is about 95%, which is really good in this case. And lastly, we will answer the task's main question, which is what will be the predicted score if a student studies for 9.5 hours a day. And here, using our model, we can see that we get about 93.43% score when we study 9.25 hours a day.